1.1 Statistical Thinking. The key concept when analyzing data, we shouldn't rely on blind acceptance of mathematical calculations. Sometimes numbers can be deceiving. Take a second and read through these definitions. It is going to be extremely important in this chapter to learn the terms. One thing to point out is the difference between population and sample. Population is talking about all the numbers. Sample is talking about some of the numbers. So a population might be like every citizen in the United States, and a sample might be if I just randomly sampled 500 of them or something. Example 1. In the journal article Residential Carbon Monoxide Detector Failure Rates in the US, it was stated that there are 38 million carbon monoxide detectors installed in the US. When 30 of them were randomly selected and tested, it was found that 12 of them failed to provide an alarm in hazardous carbon monoxide conditions. What are the population and sample? So remember, population talking about all the numbers, samples talking about some of the numbers. So if we're looking at the population, one example of population is when they talk about the 38 million carbon monoxide detectors, because that's all of them. And if you think about it, if they were going to try to test them, they probably wouldn't be able to test all 38 million. So that's where your sample comes in. Sample is just some of them. So 30 of them be your sample. The process involved in a statistical study. So take a second and read over this. You've got three main parts of this: prepare, analyze, and conclude. And each of those three are broken down into subparts and more subparts. Prepare has context, like what do the data represent and what is the goal. Source, look for bias and special interests. Sampling method, again, look for bias and in the way that the data was collected. When we analyze, we could graph or explore the data and apply statistical methods. And then when we conclude, we talk about these terms: statistical significance and practical significance, which we'll define later. Number 2 says, discuss the prepare step of the process involved in a statistical study regarding these data. So let's check it out. We're talking about pleasure boats in tens of thousands and manatee fatalities. So this 99 is in tens of thousands, so I guess that's like 990,000. So that's a lot. And this is some year after year after year after year after year is what we're talking about here. So it says discuss the prepare step. And to go back and look at the prepare step has these three things: context, source, and sampling method. So we want to discuss those three things. As for the context, I'm going to type it because I'm faster. The data represents number of pleasure boats and manatee fatalities. The goal is going to be, think about it. Think about what we might try to deduce from these numbers. The goal is going to be to see if there's a relationship between the number of pleasure boats and those fatalities. So there was context, and then we need to check the source. So the source was the Florida Department of Highway Safety and Motor Vehicles and the Florida Marine Research Institute. I'm just going to say ... But we need to consider the source to look for bias, and I don't see any reason why the Florida Department of Highway Safety and all these people would be biased or would have any reason to submit bad results. So this seems like a good source. And then we need to look at the sampling method. And I didn't really give you enough information to talk about the sampling method, so here goes right now. The data were collected from official government records. Again, these are probably good results, so we're going to say the sampling method seems sound. We're good. Voluntary response sample, a sample in which the respondents themselves decide whether to be included or not. You're going to see this a few times and understand that this is a flawed method. This is a flawed way to collect your results. A sample in which the respondents themselves decide. So examples are internet polls in which people online decide whether to respond, mail-in polls, again, where they decide whether to reply. The thinking is only the really, really motivated people are going to respond. Your average person might not respond, but somebody who really, really feels strongly is going to be more motivated to respond to this poll. Leads to bad results. Number 3. The television show Nightline asked viewers to call in with their opinion about whether the UN headquarters should remain in the US. Viewers then decided themselves whether to call with their opinions, and 67% of 186,000 respondents said that UN should be moved out of the US. In a separate and independent survey, 500 respondents were randomly selected and surveyed, and 38% of this group said the same thing. Those two polls produced dramatically different results. One said 67, one said 38. Even though the Nightline poll involved 186,000 respondents, the smaller poll of 500 randomly selected respondents is more likely to provide better results. And the question is why? Well, it goes back to this definition we just talked about. The 67% is a voluntary response. And those people who responded are probably more highly motivated because they feel really strongly about the issue, a lot more strongly than your random 500 people here. Okay, so why is this flawed? We'd say something like the Nightline results were from a voluntary response sample. These respondents probably felt strongly this could lead to bad results. Statistical and practical significance. Statistical significance is when we get a result that is very unlikely to occur by chance. And practical significance is when something is effective and also practical. So the question here says, which of these is statistically significant? Think about it this way. Think about it as very unlikely to occur by chance. So seeing 98 girls born in 100 random births, that's very unlikely. That's statistically significant. Practical significance is more like, is it worth it? Think about it that way. This one is it rare Statistical significance is talking about it's very rare or unlikely to occur, and practical significance is asking, is it worth it? Number 4, ProCare Industry once supplied a product named Gender Choice that supposedly increased the chance of a couple having a baby with the gender that they desired. In the absence of any evidence of effectiveness, the product was banned by the FDA as a gross deception of the consumer. But suppose that the product was tested with 10,000 couples who wanted to have baby girls, and the results consist of 5,200 baby girls born in the 10,000 births. The likelihood of this happening due to chance is 0.003%. So you see how that's very unlikely? It's very unlikely. Notice they even give you this 5% or less number. Question said, would this be statistically significant? And yes. Let's type it. This is what they say, very unlikely to occur by chance. Would it be practically significant? And I think that's a hard question because you really have to nail down the two definitions and understand the difference. So practically significant is talking about, is it worth it? And when you look at this, you're seeing 5,200 baby girls are born, and out of 10,000 births, you would expect there to be 50% or 5,000 girls. So think about it, 10,000 births and 52 of them are girls when we expected 5,000. Don't worry about this number over here. Think about that. This is not going to be practically significant. 52% is barely better than 50, which is what we would expect. This probably wouldn't be worth the time and money. Potential problems when analyzing data. Misleading conclusions. Make sure your statements are clear even to people who don't understand statistics. Avoid making statements not justified by the analysis. This is a big one. Correlation does not imply causation. Sometimes you're going to see two things that seem to be related. They both increase. One goes up, the other goes up. One goes down, the other goes down. They're correlated, but that doesn't mean that one causes the other. Sample data reported instead of measured. It says it's better to take measurements yourself instead of asking. Imagine if you went out and you were taking a survey and your poll question was, what is your weight? You might imagine that some people are going to lie about that and not give you accurate results, or maybe they just don't know. So it's better to take measurements yourself. Loaded questions. Avoid questions that are intentionally worded to elicit a desired response. This happens all the time. You might have completely, very similar questions with completely different results. Someone sees this second question and they're probably more likely to answer that question yes. Be careful of the order. Sometimes you can rearrange the order of items in a question, and that can completely change your results. Non-response, people who refuse to talk, are very different than those who do. Imagine an embarrassing question on your poll. Some people might be embarrassed to answer that correctly. The people who do talk about that don't have any reason to be embarrassed, so you're going to get completely different results depending on whether the person talks or whether the person doesn't talk. It's going to be misleading, or could be. And beware of misleading percentages.